Well, good evening, and thank you for tuning in to my presentation on classifying clothing images with the convolutional neural network. This is a neural network that I created to classify fashion images, pictures of shoes, tops, coats, dresses, and my hope is that this will be a presentation of a practical business application for that network. The objective of this project was to take the images that you see on the right of the screen and build a convolutional neural network that accurately classifies them above a 90% score, 90% accuracy score. This neural network was built from scratch, and in the end it was compared with a pre-trained model, one that was trained on many, many images and used as an industry standard today. So recently, an article was published that I know many readers can see on Towards Data Science about Men's Wearhouse using its data and its customer data to increase its sales online and establish a higher presence of online sales than compared to their brick and mortar sales. Buying clothing can be a challenge when you're buying it online. And the reason that many people are still going to brick and mortar stores is simple. It's that you don't want to buy something online and have it sent to you and not fit and have to return it. That whole process could take upwards of a week and a half to 2 weeks at times. So typically what a lot of people will do, researchers have found, is they'll search online for a product and then they'll actually go to a brick and mortar store to purchase the item. Companies like Stitch Fix, Trunk Club are really leading the industry when it comes to this personalized style. They're companies that will first you'll work with a stylist online and they'll send you a box of clothes. You can try them on and send back whatever you don't like. But people still really do like to go into a store to buy things like suits, let's say. For a company like Men's Wearhouse that really rely on the stylists in the shops, how do they compete with this growing market? Well, I think that an effective convolutional neural network like the one that I'm presenting today could be paired with a recommendation system and do a great job of giving customers the clothing items that they want while being able to go into a brick and mortar shop to try it on. And I'll explain what I mean by that. So imagine that you found this picture of this suit on any website online. It's a good looking suit. Let's say you found it on Amazon. Well, the first thing that I think of when buying on Amazon is not a suit. So let's say a customer was able to copy and paste this image into Men's Wearhouse website, and the convolutional neural network could then pair with a recommendation system and spit out suits or coats or ties or whatever the customer is after that are similar, if not the same, that can be bought on the Men's Wearhouse website or in the brick and mortar shop. That way the customer will know what is in the shop. This is just a clear example of keeping the customers that you already have and the customers being able to find what they want, where they want. So here's what the convolutional neural network looks like. This is just an example of a generalized neural network. Basically, in this case, the image of the deer is being sent through this network through every single little box that you see of all different colors and analyzed from a pixel standpoint to determine exactly what it is or categorize it. So think of your iPhone. Every time you look at your iPhone and it unlocks just with face detection, it's really taking those pictures and training itself, knowing that that's you who's unlocking the screen over a long period of time. And it's really going through a very similar algorithm or model called computer vision. And so in this image, hopefully, if everything goes right, this deer will pass through all these layers in this neural network, and the computer will say that it's a deer and not a cat or a lion or a dog. And these are the images that we are working with in the Fashion MNIST data. So hopefully, as a human, you can look at these images and categorize them. The first image is obviously a high-heeled shoe. The second image, although somewhat hard to detect, hopefully will be detected by a human as a coat. And lastly, we have a shirt. And that's exactly what we're trying to get the computer to do. And hopefully a human would look at this and have 100% accuracy. A computer, again, I'm shooting for anything above a 90% accuracy. To get a computer to do that would be an achievement. And so here are my findings. I trained 5 different neural networks, and the final model tested at a 92, nearly a 92% accuracy. It was validated with a 93% accuracy. So I met my objective in creating a network that was higher than a 90% accuracy. In this case, you want the loss to be low and the accuracy to be high. So our final model showed the lowest validation loss and the second lowest testing loss. And here's just a visual of what that looks like. Only 2 out of 15 of these images were falsely categorized. This is just a small subsample of the data overall. The women's top looks very much like a t-shirt top, but technically is a shirt. And you could see how the computer was tricked with that image. The shirt was falsely categorized as a coat here at the bottom of the screen because of I would imagine because of the collar and the long arms, and even a human might look at that and consider it a shirt. But all in all, an accuracy score of nearly 93% shows a great deal of accurate predictions, and also does leave some room for improvement. In order to work on that improvement, I would like to make future work of sort of playing with the parameters. In the image that you saw a little earlier, all of those little squares that the image passes through and gets analyzed through can be tuned and changed in various ways. And if you can play around with those parameters and tweak and tune those parameters, you might be able to increase accuracy. I'd like to also test out the data on other pre-trained networks to see if the pre-trained networks might test more accurately than my built-from-scratch network. And it would be fun to find more data to feed this network to see if it would categorize it outside of the given data set. And hopefully could be used to apply to a real-world business sense. To see more about this project, please visit my data portfolio website, and to see the code and all the work that went into it, you can visit my GitHub. Thank you very much.